In our fourth class, we had written this simple code to determine whether a given number is an even number or odd number. The program first takes an input number from the user. Then the number is typecast into an integer, and it is divided by 2. If the remainder is 0, then it is an even number, otherwise it is an odd number. In this class, we will learn how to improve this code by using the concept of functions in Python. Functions are extremely useful features in any programming language. Before we make any change in this code, let us first run the program as it is. We will enter the number 24. It says it's an even number. Let us run it again, but this time we will provide some junk input. X, Y, Z in place of a number. It throws an error, invalid literal for int. It is failing at this line, where we are trying to directly typecast the user input into an integer. Since here the input is simply garbage, it is a string, Python cannot convert that into an integer. As a result, this conversion or typecasting is throwing this error. In order to avoid this kind of error, we cannot directly typecast the input like this. Before we typecast, we have to ensure that it is actually a numeric input. So, one cosmetic change, instead of a number, probably we should use a different name here, say value. We will first do some kind of a validation here, to verify if the user has indeed entered a numeric data, and only then we will convert that to a number, using the typecast method, int, value. We will now look into the validation part. We can probably get rid of the print statement. We can directly use this input method to prompt the user for the necessary input and store it in the value field, like value equals to input message. So whatever the user types in will come to the value field. We will then validate that input and then convert that into integer. Now for the validation part, we can say if value. We will use a function called isNumeric. This function is provided by Python for any string variable. It checks if the string is numeric or not. If the string contains only digits, it will return true, otherwise it will return false. For our case, if the user input contains anything other than digits, we will show an error message. So we will say, if not, isNumeric, then colon, and we will print a message. Invalid input. This may look good, but we can make this validation even better by changing this if clause into a while loop. So this will keep checking in a loop until we get a purely numeric input from the user. Of course, we have to again take the user input after this message is displayed. So we will just repeat the same input statement here. This is better because it does not stop by simply checking if the input is valid. It tries to get the right input, and keeps trying until we achieve that result. And once it comes out of the loop, we got a perfect numeric value in the input. We can now safely typecast it into an integer and assign to our number variable. Now it should not throw any error for a garbage input anymore. Let us run it to verify. We will try with the same junk input again. It says invalid input. We can say ABC. Or we can enter anything we want. Instead of any error, it is simply asking for a valid input. Now if we enter a real number, it says odd number. So this code works perfectly. In one of the previous classes, we have also seen the teenage verification. I will just paste that code here, so that we can understand what is the role of a function in Python. It is a simple code. It takes an age input from the user with this prompt, then converts that into an integer, and then validates if it falls under teenage brackets. You can immediately guess that this line will throw a similar error if the user enters a non-numeric input. So we need to do the same validation again here. Let us remove the direct typecast, which will surely fail. And the cosmetic part, instead of age, we will name this as value. We will first validate this value before we typecast into an integer. But this will be actually a poor repetition of this code. This is not good for two reasons. One is the time waste. The second and most important reason is, if tomorrow we decide to make any change in this logic how we validate the input, if we say allow the user to enter only a positive integer number, we have to make the change in both the places. In a modular approach for coding, we never duplicate an effort, and we keep similar type of jobs in one single place. maybe within a function or module, and use that function or module wherever we need that same processing. So we will now convert this validation part into a function, and we will simply call it wherever we need to validate the user input. So we will first define a function separately that will contain these lines of code. We define a function in Python with the def keyword. Def, then the function name. Validate is the name of our function. Since we used this def keyword, the editor understood that we are into function definition, so it highlighted this name in blue, nothing else. You can also use any other name as you wish instead of this name. We have to add these brackets. Functions always come with a pair of brackets. We will see shortly what goes inside these brackets. Let us leave them as it is for now. The colon comes here following the coding style in Python for any code block. Under this function, we have to add these lines as the function body. So we will cut it from here and paste it under the function name. These lines together form a code block, and they must go inside the function block, so we have to indent each line here. Indentation marks the start and end of a code block in Python. Okay, we can now call this validate function from wherever we have to validate and input data. So here, once we receive the user input, in the value field, we will call our validate function. We will say validate. That is the name of the function, and then we need something here to validate. We need to pass some data to this function which it can validate. You can call it a link between the function code and this calling body. Here we need to pass the value field, which we have received from the user input. Now, the program will first execute this line, and from this statement, it will go into the validate function, and we need to also accept this value in the validate function. So we need to declare a variable here. It is just a variable name. It need not have the same name as the variable in this code. We can use just any name here. A copy of this value field will be assigned to this num variable when we call this function. Inside the function, it will check if this data is numeric, so we will change it to num instead of value. If not numeric, it will ask for the input again. And then, we will assign the new input to our num variable. And finally, we will typecast the num variable to integer, once we get a purely numeric input from the user. After this point, the code inside the function is over. So, the control will now go back to the calling party. We need to understand this flow of the program control very clearly. The execution starts with this line. Once this is executed, control comes here, and it calls this function with this variable. Then the control goes to the function, it executes these lines, and it again comes back. Once it is back, we need to get whatever is the final converted input, processed within the function, but we cannot access it directly from here. The function must return that value to this calling party, like an output of the function. We use the keyword return for that. We will say return number. And we need to accept or assign that return value here into some variable. So we will say number equals to this function. Now this number and this number are different. This is accessible only within the function, it is a local variable. And this is the program's variable, you can use just any name to receive the output. The function also cannot access any variable outside the function body. It cannot see anything here, so there is no conflict of names. Now, instead of these two lines here, we can also directly return this result. So we can just say here, return this. We don't need this line separately. Okay. This validate function is now a self-sufficient unit of code. We can call it from any place with the right input. Like, we called it from this point, to validate the user input received at this line. And here, once the user types in the age, we will also validate it similarly. So we will say age equals to validate and value. Now, this value will be passed to this validate function, we will get the output, and assign that output to this age variable. Then we can continue with rest of the processing as it is. So, this is how we use functions to make a modular code structure in Python. Please note one thing, we have to define a function before we can use it. For this validate function, here we have used this function, so we must define it somewhere above that. Generally, all the functions in a program are defined at the very beginning of the code, then the normal processing starts, and we use the functions wherever needed. Okay, we are ready with this code to run. But before that, let me explain how function arguments work. Here, this function displays the invalid input error message, in both the cases. However, if we want to customize that, if we want a different error message in each case, then we have to also pass the error message while calling the function, and it will display that error message. So in the function prototype, or definition, in addition to the number, we will also add one error message variable. And in place of this hard-coded string, we will simply display the error message that we are getting in the input. So replace it with that variable. And when we call this function here, we have to pass the message we want to display. Whatever we pass to a function is called an argument. We must pass the same number of arguments as present in its definition. We are passing two arguments now in this case. One string variable and a string literal, invalid, number. Similarly, in the age validation, we can pass a different error message, invalid age. So we are calling the same function with two different arguments in two different cases. Let us now run this code. Please enter a number. We will enter a garbage input. It says invalid number, which is perfect. Now, we will enter a valid number, maybe 24. Even number. Then it is asking for the age. Let us first enter a junk. It says invalid age. See, in this case, the error message was invalid number. And in the next case, it is saying invalid age. So the function calls from two different places resulted into slightly different outputs. It means, although functions are a common set of codes, we can customize them using different arguments while calling them. That is why functions are so useful. Let us enter 62 here. You are not a teenager. Yes, I am not. Okay, so far we learned how to write a function, what is a function definition, what is an argument, and how to call a function with an argument. We can have many functions within a program. In fact, a good program should have most of its functionalities divided into various functions. A function can also call another function. There is one special case where a function calls itself. It creates a recursion, and such functions are called recursive functions. We will see an example. Recursive functions are rarely used, but they are very beautiful, and you must know about them. Let us first take the user input for a number. We will then typecast the input. So, number equals to int value. To keep it simple, we will just assume that the user will type in a numeric value, because we want to focus somewhere else in this example. We will calculate the factorial for this number. If you are from maths background, you may already know that factorial for a number is defined as the product of all the integers starting with the number itself, up to number 1. And factorial of a number, say 5, is equal to number 5 into the factorial of number 4. We will use that property here to calculate the factorial. We will see how we can do that. We will code the calculation part later. Let us first design the overall structure of our program. So, after the factorial is calculated, we will print factorial of number is the result, whatever we calculate. The print function will concatenate all these parts into a single sentence to display. Now we will look into the actual processing part, how we can get this result in the calculate step, like result, equals to some factorial calculation. We will get this part in some function, so our code here remains neat and clean. This is how we should design our code first. We do not need to get into every logic or detailed algorithm right away. First build the high-level structure of your code, what input it will take and what will be the output, how the control will flow, which functions will do what. Then you can further develop each part one by one. We will now write a function for this calculation. Let us call it factorial, and within brackets, its argument. We need to define this factorial function at the top. It will take this number as the input, and it will return the factorial value, which we assign here. This is the overall architecture. And now, we will write the function code. At the very beginning, def factorial any variable for its argument, num, and then colon. In the code block for the function, we will check if num greater than 1, then return num into factorial of num minus 1. And in the else part, we will simply say return just 1. And we are done. So, you can see, on certain condition, this factorial function is calling itself internally in its code. As long as this number is greater than 1, it will keep calling itself in a loop, to get the factorial of the previous numbers, creating a stack of numbers up to 1. But it won't get into an infinite loop. Once it hits 1, it will start wrapping up the stack, multiplying each number with the next number up to the given number. This is called a self-calling function or a recursive function. Once it wraps up all the levels in the stack, it will return the final product or the factorial to the calling body, and we are assigning that factorial to this result variable, and then printing it. Let us now run this code and verify. We will try with the number 6. Factorial of 6 is 720. Perfect. This is how a recursive function is written. Do not worry if it seems too complex to you at the first glance. As I said, recursive functions are rarely used. So, as a beginner, you should focus on writing simple functions and building modular programs. You can try the exercises given below. Once you feel more comfortable, you can come back to this recursive function. In this class, we have seen how we can write a function and use it from anywhere within the code. You can also reuse a function in another program, in another file. We will learn about that, along with external reference, in our next class, when we learn about how to import a module. I hope you like this tutorial. Thanks for watching, and don't forget to subscribe to this channel.